Welcome. This is a revision guide for glaciation. This is brought to you by SRC Bede Sixth Form Geography Department. The information in this presentation relates to the EDUCAS specification, which is the linear specification. First of all, we've got to establish what are glaciated landscapes and what is glaciation. Within this, we've got to establish what the key features of glaciers are, what impacts upon glaciers, what are the impacts of glaciers on the environment around them, how can glaciated landscapes be perceived negatively, and how can sometimes data on a wider scale relating to climate change trick us with regards to glaciation. Glaciation is a relatively simple concept to understand. It is a large mass of ice that moves downhill due to gravity. As that occurs, we can break the glacier down into two zones, the zone of accumulation and the zone of ablation. The zone of accumulation is the area in which we see inputs into the glacial system, and the zone of ablation is where we see the outputs. The line marking the difference between these two zones is known as the zone of equilibrium. This fits into our specification as, first of all, you've got to know what a glacial system is and what are the dynamics of it. As part of this, you've got to understand glacial mass balance, the impacts that climate change has on glacial budgets, the relationship between climatic fluctuations and the work done by ice, and the different types of glaciers. Glaciers are something that are very fun and easy to investigate, but the actual science of gathering data can actually be very complex. Luckily for you, we don't have to know too much about that. Data on glaciers and their formation is gathered by scientists. The scientists try to plot how much glaciers are moving. One way in which they do this is they place ranging poles into the glacier and then calculate how much they've moved over a period of time. Another more scientific way to do this is to use GPS and to map the movement of the glacier's snout and the thickness of glacial ice. Going on to the glacial system. The inputs into the glacial system tend to be in the form of snow and rain. It can also include rockfall. Therefore, the inputs are more likely to increase during winter months or at higher altitudes. This leads to accumulation within the glacier. Glaciers involve a number of processes. There are three erosional processes: plucking, abrasion and freeze-thaw. In addition to this, we have the processes of transportation and deposition. All of these will be explained in more detail in another video. And finally, we have the outputs. Outputs come in two forms: meltwater and moraine. So let's define some of these terms. First of all, looking at snow and rain, we would prefer if you called this precipitation and then broke down and defined it. Looking at the term moraine, moraine means material deposited by the glacier. This can form in a number of ways, which will be explained later. Glaciers are something that actually takes a very long time to form. It's not something that's going to pop up overnight. Glaciers originate from heavy snowfall. The snow has many spaces between them. Over time this compacts. This will result in the colour of the glacier sometimes changing. What we have first of all is névé, which is snow which is deposited in a hollow, and then when this compacts it turns into firn. One thing to remember is that glaciers, although large bodies of ice, do actually move. They form in areas where temperatures are sufficiently cold enough to allow them to exist from year to year, and they can range in size, from the very smallest valley to areas which cover huge continents. An example of areas where huge continents are covered are Antarctica and Greenland. Glacial ice is very important. At present, glacial ice covers approximately nearly 15 million kilometres squared, or 10% of the Earth's land surface. This can relate to climate change due to the reflection due to the albedo effect. One thing that is important with glaciers is the concept of the ice budget. The ice budget is the concept that the glaciers will grow and retreat depending on how much precipitation is inputted. The growth can be seen on two scales. One way to look at it is every year, or another is to look at it over a much longer time period. What you will find is that a glacier may actually advance and retreat during a year, depending on when ablation and accumulation occurs. We need to know two key terms. One is a positive regime and the other is a negative regime. A positive regime occurs when the accumulation is greater than ablation. A negative regime occurs when the ablation is greater than the accumulation. What we've got to understand is that the concept of the equilibrium line can actually move. The equilibrium line depends on the amount of accumulation and ablation. It is at the point where these two processes are in balance. You may be asked in the exam to identify the location of this on a glacier based on statistical data. Glacial budgets can be shown on a yearly scale. If this is the case, you will tend to see some very simple trends identified. One trend is two periods of net mass gain, generally occurring in the time periods we'd identify as being winter, and net mass loss occurring during the summer months. So what affects this? First of all, if the temperature goes down, there is more likely to be freezing and therefore mass added to the glacier, whereas in the summer months, if the temperature rises, there's going to be more evaporation, leading to water and volume loss from the glacier, including meltwater. We've got to then think of climate changes that occur in relation to and affect glaciers. Glaciers are affected by climatic fluctuations both on a short-term scale and a longer-term scale. On a longer-term scale, glaciers can retreat if there is an increase in temperature. This increase in temperature can be very minimal, less than 1 degree, yet can result in a significant loss of ice. You've got to bear in mind that the Earth's temperature tends to vary only by about 6 degrees between ice ages. What you've also got to understand is that if the predicted climate change occurs, there will be increased losses during the winter months